Alright, so today in this video I will try to cover up the algebra of limits and also some of the questions related to limits and how to solve them for a better understanding. So let's just start with the algebra of limits. So let's suppose there exists a function limit x tends to a function of x is equal to, let's say, L, and limit x tends to a g of x is equal to m. Then first limit x tends to a f plus minus g of x is equal to limit x tends to a function of x plus minus limit x tends to a g of x. And then the second property would be limit x tends to a f g of x or f into g of x is equal to limit x tends to a function of x into limit x tends to a g of x, and this would be equal to L into m, and this is L plus minus m. And then the third property would be limit x tends to a f by g of x or f divided by g of x would be equal to limit x tends to a function of x upon limit x x tends to a g of x. This would be equal to L by m provided m is not equal to 0. And then the fourth property would be limit x tends to a function of x raised to power g of x is equal to L to the power m. So these are the algebraic operations of limits, and then we'll move on to next topic. We'll just get to the questions regarding these in a while. So what I want to teach new in this video is what greatest integer function is, because actually it is really important to understand the questions of limits. So we'll be doing greatest integer function, and it is denoted by the square brackets and x. So if you get a number in square brackets, then basically that's greatest integer function. So what exactly is greatest integer function? So let's say you have a number x, and x can be written as so this is basically greatest integer function. Then what is it? It would be fractional part of x. So for example, if I take 5.2628, so it would be 5.28 plus 5.28. So like the brackets, they play a very important role in distinguishing between the greatest integer function and the fraction part of whatever the number is given, x in this case. So the greatest integer function would be for 5.28, 5 plus the fraction part is 0.28. So if you add them up, you again get 5.28. So let's say if we have a positive number a, and this is, let's say, a plus 1. So let's say I take a number between a and a plus 1, let's say a plus h. So basically we know h is less than 1. That means 1 is greater than h. Therefore, greatest integer function of a plus h would be equal to a. So for another example, let's take pi, which is 3.14. So 3.14 can be written as the greatest integer of 3.14 would be 3 plus the fractional part, which is 0.14. So yeah, so curly brackets is for fractional part, and the square brackets for greatest integer function. Or you can also write it as integral part. So let's learn how to evaluate left hand and the right hand limits. So basically left hand limit is, let's suppose, written as x tends to a negative function of x, and right hand limit is written as x tends to a positive function of x. So we cannot just put in the value of a negative and a positive in place of x. So what do? We try to replace a with another limit, let's say h. So what we'll do is, we know that when x tends towards a negative, that means obviously x is less than a. So let's suppose x is equal to a minus h. So as x approaches to a, h approaches to 0. So we can write limit h approaches to 0 function of a minus h. And similarly, in this case, we know that x is greater than a because it is approaching a towards the right hand side of the number line. So we can write this as x is equal to a plus h. We are writing plus because obviously x is greater than a. So as x approaches to a, h approaches to 0. So we can write it as limit h tends to 0 function of a plus h. So now we'll be doing some questions on these. So let me just write the questions. Alright, so let's just start with the first question of the video. Function of x is given by mod of x minus 4 upon x minus 4. X is not equal to 4 and 0 at x is equal to 4. So let's find the left hand limit at x is equal to 4. So what we'll do is, we know we'll just write left hand limit x tends to 4 negative mod of x minus 4 upon x minus 4. So what we'll do is, let's suppose as x is the left, as we are dealing with the left hand limit, that means x is tending towards -4, like 4 negative, sorry. So x is smaller than 4. So what we'll do is x is equal to 4 minus h. So when x approaches to 4, h approaches to 0. So we'll apply the new limit. We'll do limit h tends to 0 and then use this in terms of x. We'll do 4 minus h minus 4 mod upon 4 minus h minus 4. Yeah. So we get 4 minus 4 0. Get minus h upon mod of minus h upon h minus h, sorry, is equal to h by minus h minus 1. So let's just suppose we are also given to find the right hand limit. What we'll do is we'll write limit x tends to 4 positive function of x. Let x be 4 plus h. That means we can do as x approaches to 4, h approaches to 0. So we'll apply another limit h tends to 0. 4 plus h minus 4 mod upon 4 plus h minus 4. This cancels, is equal to mod of h upon h is equal to 1. So in this case, we can see that left hand limit is -1 and the right hand limit is 1. So we can write -1 is not equal to 1, hence limit does not exist, and write the formula limit x tends to 4 by x minus 4. So I'll be writing the next question now. So the given function is f of x is equal to 1 plus x square if this is the given equation, and 2 minus x if x is greater than 1. Show that limit x tends to 1 f of x so we have to show that limit x tends to 1 does not exist. That means we have to show that left hand limit is not equal to right hand limit. So let's start with left hand limit. Limit x tends to 1 negative function of x. So let x is equal to 1 minus h. So as x approaches to 1, h approaches to 0. So we'll do limit h approaches to 0. So we have to pick the case in which x is less than 1. So this is a case where x is less than 1, so we'll use this equation. And in terms of x square, we will write 1 minus h whole square. So we'll write 1 plus 1 minus h whole square. So put h is equal to 0 we get this as 0 and 1 square is 1, so 1 plus 1 is equal to 2. So this is the left hand limit. And for right hand limit, limit x tends to 1 positive, function of x, let x is equal to 1 plus h. As x approaches to 1, h approaches to 0. So limit h tends to 0. So now we have to pick the case in which x is actually greater than 1. And here x is greater than 1. So we'll use this equation. 2 minus 1 plus h. Put h is equal to 0. We get 2 minus 1 is equal to 1. So we can clearly see that 2 is not equal to 1. Therefore, left hand limit is not equal to right hand limit. Hence, limit x tends to 1, function of x does not exist. So the third question is, discuss the existence of limit x tends to 0, 1 by x. So this is actually an easy question, so you can pause the video and try to do it yourself, and I'll just do it right now. Alright, so let's just start with the left hand limit. So we can do x is equal to 1 minus h. As x approaches to 1, h approaches to 0. So we'll do, limit h approaches to 0. Wait, this is 0 minus h, sorry. As x approaches to 0, h approaches to 0. Limit h tends to 0, 1 by, so this is going to be negative h. So when the denominator is approaching towards 0, we get positive or negative infinity. So as this is negative h, we can write minus 1 by h. So as h is tending towards 0, we get the whole value as negative infinity. So for right hand limit, x is equal to 0 plus h. As x approaches to 0, h approaches to 0. So limit h tends to 0, 1 by h is equal to positive infinity. So this is negative infinity and this is positive infinity. Hence, left hand limit is not equal to right hand limit. So we can say it does not exist. So the given function this time is (4x minus 5) if x is less than or equal to 2, and x minus 5 if x is greater than 2. So find phi such that limit x tends to 2 function of x exists. So basically when a limit exists, that means the left hand limit is equal to right hand limit. So in the previous cases what we found was that the limit does not exist. Why? Because in each of the questions which we did before, the left hand limit and the right hand limit, they were not equating as equal. So hence we can conclude that to find out if a limit exists or not, we have to find out the left hand limit and the right hand limit, and they must be equal. If they do not be equal, then the limit does not exist at that particular value of x. So in this question what we have to do is we have to prove left hand limit is equal to right hand limit. So we have to prove it, because if left hand limit is equal to right hand limit, this implies limit exists. So let's go with the left hand limit. Let x be equal to, so 2 negative, so it would be 2 minus h. As x approaches to 2, h approaches to 0. So we'll do limit h approaches to 0. So we have to pick out the equation in which x is less than 2. So here x is less than or equal to 2. So we'll go with this one. 4 into 2 minus h minus 5. This would be equal to 8 minus 4 h minus 5. Put h is equal to 0. This gets 0. So 8 minus 5 is equal to 3. So in case of right hand limit, put x is equal to 2 plus h. As x tends to 2, h tends to 0. So limit h tends to 0. So here x is greater than 2. We'll do 2 plus h minus 5. Put h is equal to 0. We get 2 minus 5. And this is the right hand limit. So we can conclude 2 minus 5 is equal to 3. Therefore, minus 5 is equal to 3 minus 2 minus 5 is equal to 1. Therefore, 5 is equal to minus 1. So this is the answer. So we have 3 equations this time. This is x, this is n. Nx plus m and nx cube plus m. So we need to find out the values of m and n for limits x tends to 0 function of x and limit x tends to 1 function of x exist. Alright, so in case 1, you can just directly put the value of negative h and positive h, because if we do not do so, this quotient is going to take a lot of time. So we'll do limit wait, this is x 0 negative and 0 positive. So here x is less than 0. So in this case x is less than 0. So we'll do m into minus h square plus n is equal to, here x is greater than 0 and in this case x is greater than 0. So also x is greater than 1, that does mean that x is greater than 0 as well, but that is what limits are about. X is greater than 0, that means x is just greater than 0. So the gap is like infinitely small or infinitesimally small between x between 0 and x. So we'll go with this equation. So is equal to n into minus h plus m. So we also have to write limit h tends to 0 and limit h tends to 0. So put this gets cancelled, this gets cancelled. So we get n is equal to m. So for limit x tends to 0 function of x, for this function, for it to exist, first case in first case n would be equal to m. For second case, let's see. So the equation was limit x tends to 1 function of x. This would be 1 minus h, yeah. So less than 1, n into 1 minus h plus m is equal to, greater than 1 plus h cube plus m. Again, limit h tends to 0, limit h tends to 0. So put h is equal to 0, we get n into 1 plus m is equal to n into 1 plus m. So we get the equation as n plus m is equal to n plus m, which is going to satisfy every single value for n and m. So we have to find the values of n and m together for these two limits. So we'll go with this one. Therefore the answer would be m is equal to n for limit x tends to 0 function of x and limit x tends to 1 function of x to exist. basically the main idea of the question, like it's just the same as the previous ones, just there are a lot of variables which can actually confuse you in the start, but if you go on to try the question, so you won't actually find any difficulty. So it's just a lot of variables which can actually, put students into some dilemma. So they will just leave the question, but it's just simple as the previous ones. So yes, you just have to try it. So solve for one limit separately and then solve for other limit separately, and equate left hand limit and the right hand limit for the limits to exist. Alright, this is an important one. Show that limit x tends to 0, e to the power 1 by h minus 1 upon e to the power 1 by h plus 1 does not exist. It's 1 by x. So we get limit h tends to 0, e to the power 1 by minus h minus 1 upon, actually it's h, yeah, minus h, sorry, upon e to the power 1 by minus h plus 1. So it's like 1 by minus h is equal to minus 1 by h. And let's say you get a to the power minus b, which is equal to 1 by a to the power b. So we'll do h tends to 0, 1 by e to the power 1 by h minus 1 upon 1 by e to the power 1 by h plus 1. So let me rewrite the equation. So as h approaches 0, 1 by h approaches infinity, and e raised to power 1 by h would be e raised to power infinity, that would be infinity. So 1 by infinity is always 0. So we get 0 minus 1 upon 0 plus 1 is equal to minus 1 by 1 minus 1. So basically left hand limit was equal to minus 1. So for right hand limit, we'll do x is equal to 0 plus h. As x approaches 0, h approaches 0. So we get limit h tends to 0, e raised to power 1 by h minus 1 upon e raised to power 1 by h plus 1. So if you just directly put the value of h is equal to 0, we get infinity minus 1 upon infinity plus 1, which is again the infinity by infinity form. So how do you deal with such equations? What I can do is, I can divide the numerator and the denominator by e raised to power 1 by h, and after that this becomes 1, this also becomes 1. So I get 1 minus 1 by e raised to power 1 by h upon 1 plus 1 by e raised to power 1 by h. So again, as h approaches to 0, e raised to power 1 by h approaches infinity, and 1 by e raised to power 1 by h approaches 0. So I get 1 minus 0 upon 1 plus 0 is equal to 1. And left hand limit was negative 1. So right hand limit is equal to 1. Negative 1 is not equal to 1. Hence limit does not exist. Alright, now comes the question of greatest integer function. So the question is, find limit x tends to 2 greatest integer function of x. So left hand limit that x is equal to 2 minus h as x approaches to 2, h approaches to 0. Limit h tends to 0, greatest integer function of 2 minus h. So h is less than 1 and is greater than 0. So if I create the number line, this is 2, this is 1, and the number is going to lie somewhere here. So basically for this number, the greatest integer would be 1. So its greatest, so basically the value of this greatest integer function of 2 minus h would be 1. Therefore, left hand limit is equal to 1. And for right hand limit, let x is equal to 2 plus h. As x approaches to 2, h approaches 0. So limit h tends to 0, greatest integer of 2 plus h, as again h is greater than 0 but less than 1. So this is going to lie somewhere here. So the answer would be 2. So basically right hand limit is equal to 2. So left hand limit is not equal to right hand limit. Therefore limit does not exist. So the next question is, prove that limit x tends to a positive greatest integer function of x is equal to a for all, this is for all a belongs to r is set of real numbers and this is a sign of belongs to. So in this case we are specifically given the right hand limit, so let's just solve. Let x is equal to a plus h as x tends to a, h tends to 0. So we can write limit h tends to 0 a plus h. So here we know h is greater than 0 but less than 1. So the value would be a. So basically we can again write limit x tends to for all a belongs to r. Alright, now comes the last question for the video. Let a1, a2, so on up to an be fixed. This is fixed fixed numbers such that the given function is x minus a1 into x minus a2, so on up to x minus an. What is limit x tends to a1? X tends to a1 function of x. And the second question is, for a not equal to a1 comma a2 up to an, compute limit x tends to a function of x. So I guess this is like the simplest question of the video. It just looks kind of weird at like the first glance. So just try to solve this question yourself at first. Like I'll definitely solve the question, so you can try the question yourself. So I'll just start solving in 5 seconds. So yeah, so if you put the value of x as directly a, you cannot get any indeterminate form like I discussed in the previous video. We are not getting infinity into infinity or 0 by 0 or infinity by infinity form. So we can just directly put the value of x is equal to a1, right? So function of, so x is equal to a1 is equal to a1 minus a1 into a1 minus a2, so on up to a1 minus an. So simply if this becomes 0, everything becomes 0. Therefore limit x tends to a1 function of x is equal to 0. As simple as that. So for the second question is just the same. It's like direct substitution of x is equal to a. Like here it was x is equal to minus a1. Here Here it's simply going to be x is equal to a. So for second part, it's just a minus a1 into a minus a2, so on up to a minus an. So yeah, that's it. So these were the questions for the video, and I hope you really enjoyed doing the questions because they were like too simple, and maybe one or two were tricky. So yeah, you can practice these questions. You can again go through the video. You can go through the through the previous video as well. And I'll be bringing some more questions for the next video. So yeah, that's it for today. Thank you for watching.